Recording is rolling. It is Friday, April 11th. You guys picked up your electricity quizzes from your folders. You guys can do corrections like normal. So if it's a conceptual question that you missed, you can just write out the sentence for the correct answer. If it's a calculation question, there was a lot of Ohm's law and a lot of Joule's law, but those are your main two, right? Ohm's law and Joule's law. Then write out the equation that would lead you to the answer. For that Kirchhoff table on the back, if you missed any of those, then I did write in pink ink the correct answers to just show how to get to those. And you guys can enter that in next week. I'll give you guys partial credit back. But main activity today is going to be orienteering. Orienteering. So everybody should have a treasure map. You guys got a treasure map? I need to show you guys how to read this, what you're looking for. So there's some treasure out there. Now, there's different versions of this treasure map, but they all lead to the same treasure because there's only one treasure. Everybody's starting at the same location. See, it says start at the west end field goal post. And then you'll follow a series of steps. And what you're looking for at the end is I staked one of these in the ground. You guys see this right here? So where the treasure is buried, and there is buried treasure out there. I staked one of these. So from above, now this would be flush with the ground. It looks about the size of a dime. You guys see it? You guys think you can find that out of the field? And then whoever finds this first, I will give you this pirate shovel, and you can dig up your pirate treasure. So how do you read bearing here? Oh, I should have a map back here. Here we go. So the practice field behind the skull. So here's the skull right here. Here's the skull. We're gonna take the stairs down, walk out, and you're gonna run into the west end field goal post is closest to the skull. And this field makes pretty much almost exactly an east-west line. So we're gonna call this east-west. Because which way is north? Maybe this way. That way's north. And that way's south. Okay. Right, so let's get a better aerial view of this. Suppose you're a hawk flying over. Hawk flying over. You're gonna look straight down on this field. Straight aerial view. Because the field from above, got a little compass rose over here. Got north, east, south, west. So here's your west end field goal post. This is where you guys start. So you guys know the school is on the left side because we're coming from the. Okay. Here's your west end field goal post right here. So everybody knows to start here. Right. And let's follow these directions. So what does this say? It says walk so many meters and then so many degrees. So there's a direction there. Right. Let's start with meters here. Meters. How do you know how far to walk in terms of meters? Now, I've done this activity many years, and students are usually pretty good at figuring out what a meter is, like how to pace off meters. So I will put this meter stick down on the floor as you guys are walking out. You guys know 1 meter is about 3.28 feet. You guys know pretty close. Okay. So that was that like 3¼ floor tiles. If that helps. Now I know if I'm just walking regularly, every step I take is about 70 centimeters. So I know if I take 2 short steps, that's probably pretty close to a meter. Or I could take giant pirate steps, and each of those could be a meter. So you figure out exactly how you want to pace off a meter at a time. Okay. Let's see if I'm following these steps though. Says so many meters. See, 45 degrees east of north is my first direction there. So from the western field post, here's my north-south line. Do you guys notice that all these directions, if you look at all the directions real fast, you see they're all relative to a north-south line? So many of north, of south, of south. And you might have a little bit different looking map, but it always says so many degrees, and then east and west of a north-south line. Okay? So here's my north-south line right here. You see north-south? If I want to go 45 degrees east of that, is that 45 degrees east of north right there? East of north? Okay. If I want to get this accurately, I got a protractor here. So here's the node at the west end field goal post, 45 degrees, bam. That's sort of off in that direction. Now, I don't know if the distance is exactly to scale, but I know this angle is. That's 45 degrees east of north. Can you guys get east of north? Okay. So remember, bearing was just a convention that people kind of came up with. Bearing is always relative to a north-south line. And then you pick up from that point. So you'll be some random place out in the grassy field. Oh, let's see. So many meters, 30 degrees east of south. So let's get another north-south line. I need to go 30 degrees east of south. Is that? It's about right there, in that direction. So see what it look like. East to south, 30 degrees, bam, that's that direction. So I'm going sort of that way. Again, I don't know if my distances are to scale exactly with the map, but it would be in that direction, wouldn't it? This could be your 30 degrees east of south. Everybody good so far? All right. And then you'll be at some other random place in that big old grassy field. One more step. So many meters, 30 degrees west of south. So need one more bearing line, north-south bearing line. All right, so I got my north-south line. I need to go 30 degrees west of south. Well, that's like, it's about that direction right there. Let me check. So what's 30 degrees west of south look like? It's 30 degrees west of south. Somewhere about there. Okay. So that looks probably right about there. Do you guys think? Is it? Right. So let's follow those steps in order. Right. Now, here's another idea. Are these vectors? Did I just connect a bunch of vectors tip to tail? Vectors? I did, didn't I? These are displacement vectors. Oh, hey, if I wanted to follow these directions out of order, suppose I want to start with the second step first and third step and then on the first step or any order. Ask you guys, would you end up at the same location at the end if you follow these directions out of order? Do you end up at the same location? How many of you guys think you do? Who says yes? Yeah, there's my winners right there. There's my winners. You do. You guys remember vectors, you can add it together in any order. Show you guys a similar idea. Let's do force vectors. What if I have 3 force vectors on this object? So force that way, force this way, and force this way. Let's say those are all simultaneous. Okay. And I want to figure out, well, what's the net force? Like maybe I could break these into components, sine and cosine, blah, 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 right? But there's no particular order that I have to add them up. I could add them in any order. I should get the same resultant, right? The same net force. Right? So replace force vectors with displacement vectors, and it's the exact same idea. In fact, that's exactly how I made different versions of maps. Is all I did was I just rearranged the order of the steps, just so that you guys aren't on one giant ball. You guys can kind of split up, right? or find some teammates you guys want to walk with. Okay. All right. So you guys know what you're looking for. You're looking for a stake in the ground. Bam, about like that. You guys find that? All right. You guys ready to find some treasure? Treasure. It's a treasure time. Treasure time. Treasure time.